Good morning, friends. Today's we have to discussion the algorithm techniques. First of all, we have to see the what is algorithm and what are the characteristics of algorithm. Next, we have to proceed the algorithm techniques. First step, define algorithm. Here we have to 19th century Abu Jafar Muhammad was introducing the define the algorithm. He was put the name in algorithm. We have to follow the number of definitions here. We have to first one is an algorithm is a sequence of computing steps that transport the input into output. The algorithm is a sequence of operations performed on the data that have been organized in a data structure. Here we have to take in the some sequence of steps of the solving a problem to get the expecting output. This is the one of the algorithm definitions. This Another one, an algorithm is a step-by-step procedure to solve a program in natural language. The algorithm is defined as a sequence of statements which is used to perform a task. Here we have two same definitions. Here we have to first definition, second definition, third definition. Here we have to follow the same meaning, but we have to take in the terminologies differences. This is the algorithm. This is the rotations of the algorithm. First of all, we have to take in the one problem. That problem having a that problem we have to solving the number of we have to written in a stepwise. Here stepwise we have to written in that one is a algorithm. Next one we have to algorithm we have to read write a program. We have to get in the computer input, we have to give in that we have to get the output. This is one of the rotations of the algorithm. Next we have to see the characteristics of the algorithm. Here, here we have to every algorithm must satisfy the following this characteristics. First one is input. In every algorithm having a zero inputs or a one input. So we have to considering as the algorithm having a zero or a well defined inputs. Next one is a output. And every problem having a solve, we have to return a some problems, some solution. Each solution having a get a one output. That's why we have to algorithm having a one or a more output displaying in finally. This is an output. An algorithm must be have a one or a well defined output and should match with the designed output. This is the output. Next one is next characteristics is a definiteness. Definiteness means each instruction having a meaning. Each instruction having a clear to cut. This is a work for this instruction. Suppose we have to written in a print statement. We have to suppose we have to written in any addition statement. That work is a only we have to then addition of the two numbers or a three numbers. This is a one clear cut we have to written in the instruction. Next is a fitness. Sorry, finiteness. Here finiteness means we have to finiteness means having in every algorithm having a number of steps. After number of the step execution, after the number of the step is completed, then we have to go to the terminate. This is the one of the finiteness. Every algorithm having a some of the step execution, then we have to go to the terminate. This is one of the finiteness. If you track out of the instruction means steps of an algorithm, then for all the cases of algorithm will be terminated after the finite number of steps. Definite effectiveness. Effectiveness means next one is effectiveness. Every instruction must be rule. We have to in every instruction must be we have to written in a paper. Means we have to carry the every way. This is the one of the finiteness. Means what is the flexibility? We have to carry the everywhere in the algorithm. This is the finiteness. And the next one is a feasibility. It must be feasibility enough to protect the any instruction of the algorithm. Next one is a flexibility. Flexibility means we have to carry the anywhere we have to algorithm, and it is a enough to carry out the design changes without any no effect. Next is a effectiveness. Effectiveness means we have to hear which algorithm is a how fast we have to solve the problem. We have to analyzing some steps. We have to here we have to calculating the time and a space dependency. We have to analyzing the algorithm or effectiveness of the algorithm. We have to using the time and a space. So an algorithm must be ensured that it is take the little time or a less more space consuming. It is a one of the effectiveness we have to. This is one of the characteristic. Next one is independent. Here algorithm we have to returning in a general English. So we have to returning the, this is a, one of the independent algorithm. An algorithm must be have a language independent, which means that it is a mainly focused on the input and a procedure we have to solve in the solution and a problem, and it is we have to get the output. This is one of the characteristics of the ratio. These are a characteristics of the every algorithm following input, output, definiteness, finiteness, independent, flexibility. These are a characteristics. Next we have to see the main was a algorithm designing techniques. Here every algorithm having a solve the problem. This means the every problem is a solving having a some of the many solutions, but you have to here using to the some techniques we have to solve the problem. Here we have to discussion the several techniques. Mainly we have to discussion here five techniques: divide and conquering, greedy method, dynamic programming method, and a backtracking method, and it is a bench bones method. First one is a divide and a concrete. Here, divide and concrete means first we have to take in the problem. That problem we have to divide in the two parts, and that part we have to again divide it. Up to we have to sub. Up to we have to two sub problems or a one. We have to reach the one sub problem. Then we have to it is a dividing first step. Second one is a concurrent. Concurrent means we have to solving the each sub problem, that we have to get the solution. Solution of the every sub problem individually. This is the concurrent. Next we have to combine them. We have to third step is combine the sub solutions. We have to combine the all sub solutions. We have to get the solution of the whole problem. This is the divide and concurrent. Here divide and concurrent has a three parts: divide, concurrent, combined. See, we have to diagram here. Here we have taken the one problem. The problem is divided into a sub problems, and a sub problem is a we have to getting the second step is concurrent, means we have to solving the sub problem. Next, finally, we have to combine the entire sub problems. We have to get the whole problem of the solution. This is the technique of the divide and conquering. What are the applications of the divide and conquering? Towers of Haney, binary search. Here we have to see that also sorting techniques also. Merge sort, quick sort. This are a coming in the divide and a concrete applications. The second one is a greedy method. Second one is greedy method. In greedy method is a used to solving a optimizing a problem. Here we have to get the optimizing problem. Suppose we have to taking the some example. One example. Here we have to move city A to we have to move the city B. Clear? We have to suppose we have to go to the Vijayawada to Tirupati. Then then which way we have to go to? First way we have to number of ways. First way we have to something we have to take in the walking, bus, train, and aeroplane, autos. These are a number of ways. We have to number of ways. Here we have to go to the number of ways. The problem is traveling the A to B. There is a number of solutions. You can go like this way, take this one, and go there. But there is a no constraint. But there is a constraint in this problem. Here there is a we have to constraint in this problem. I have to carry the this journey Vijayawada to Tirupati. We have to within a 24 hours we have to reach that. So I cannot. So we have to go to the easy way. We have to go to the aeroplane or a train. These are two better ways. So we have to take in the optimizing solution. Here optimized solution means we have to maybe in based upon the problem situation take the minimum or a maximum problem. In this situation we have to go to the constraint is a 12 hours we have to reach the destination. Then we have to take in that 12 hours means we have to 1 day. 12 hours we have to go to 1 hour. Actually, we have taken the aeroplane. Aeroplane is the best option. This is the destination to reach in this problem. Okay, this is the greedy method in which solution is satisfied that problem. Then it is a type of the solution become a feasibility solution. Okay, which solution is satisfied the given problem. Then the type of the solution become called as the feasibility solution. Here feasibility solution means satisfy the constraint. Here we have taken some constraint. We have to reach the 12 hours to Tirupati. This is one of the constraint. This is one of the constraint. Here I will just say that journey in a minimum cost. Suppose we have to cost. We have to basing a constraint based upon the cost. Then we have to spend the as much as a less possibility than this become a minimizing a problem. Means we have taken a minimizing cost. That it is in this situation we have to try and is the best. This is the greedy method. Greedy method is solving the problem based upon the optimizing problem. Here optimizing problem is required to neither maximum or a minimum result. What are the applications here? We have to using the applications or a critical prints, minimum spanning tree. These are a coming upon the applications here. Next one is a thought dynamic technique is a dynamic programming. Here dynamic programming is also used in a optimizing problem like a divide in a concurrent method divided. Here dynamic program is an algorithm designing method. This is also a one of the technique to solving a problem. Here we have to take in the complex problem. The complex problem is a breaking into a sub problem, solving the each sub problem just once, and it is a storing in the result in the arrays. It is a solving the sub problem that we have to store that value in a result. Dynamic program is a follow the some principle. That principle is called as the principle of the optimality. Principle of the optimality. Overlapping subproblem and optimal subproblem. Optimal substructure. Optimal substructure. Here, optimal substructure means here we have to given the problem as an optimal structure property with the optimal solution of the given problem. We have to take in the optimal solution of the given problem. Can be obtaining by the using optimal solution of the subproblem. This is the optimal subproblem. Suppose we have to take the example. Shortest path problem is the following from source U to destination to. Then we have to take the intermediates in shortest path U to U to X and X to. This is the overlapping structure and there is optimal structure. Second one is overlapping substructure. Here overlapping substructure is approach, like a divide and concurrent approach. Dynamic programming combine the solution of the subproblems. We have to take in the combine the subproblems. Dynamic programming is a mainly here we have to mainly using the when solution to solve a subproblem. Here we have to solve the subproblem. We have to need again. Here we have to solve divide a subproblem. Each subproblem is a divide. Calculating the again. Each subproblem means we have the first subproblem is a again we have to see the another subproblem. Then we have to calculating that two times. This here we have to need not to again calculating. We have to store that value in a some particular table format or a array format. This is the we have to do not need of the again calculating the subproblems. This is a here. This is a overlapping subproblem. Here we have to see the next one is a applications. Here applications for a we have to see that here all fate shortest path discharge. This are coming on a dynamic programming. Here we have to follow the four steps. First one is a characterized steps of the optimal solution. Next we have to recursionally define out the value of the optimal solution. Next we have to solving the problem in a bottom fraction, and we have to considering some optimal solution by using that dynamic solution. Applications. These are the applications. Maximum chain multiplication. Matrix chain multiplication. Traveling salesman problem. And the logist common subsequency. Backtracking. Here backtracking means we have to solving the backtracking means it is one of the solution of the problem, solving the problem. And here we have to using the board force searching technique. We have to using to solve the backtracking. It means to search the solving the problem number of a problem having a number of solutions. All possibilities we have to take in that one and pick up the best solution from the design solution. Here a dynamic program is a solving to the optimizing problem. Same rule we have to follow the dynamic programming heavy dynamic problem. But here we have to backtracking is not used for solving the optimizing problem. We have to take in the number of multiple solution. We have to require all the solution. Here we have to go to the solution. We have to get the solution. In another way, here the problem is the number of problems, number of solution. Then we have to when the solution we have to solve it. Again that step having a go to back. We have to get the another solution. We have to this is one of the backtracking technique. Here we have to using the BFS generating to generating the state space tree solution. Here we have to take in the some sample of state space tree solution. We have to try the backtracking. These are relatives leave node, E node, success node, and dead nodes. These are A nodes in a backtracking. Here we have to follow in the two constraints, implicit constraint and explicit constraint. How elements are a tuple or a relating. This was are implicit constraint. And explicit constraint means a restrict with each element as a choose for a given of the set. These are applications of the n-queens problem, sum of subset problem, graph coloring. These are applications of the backtracking. Branch and bones is similar to the backtracking, but we have to using here a BFS. Here we have to take in the BFS to construction the state space tree. And next we have to here mainly we have to solving this optimizing problem. That optimizing problem is a minimizing a problem. Here we have to take in the constraint only minimizing a problem, but we have to bench and bone we have to solving the problem is maximum. Then it is maximum as we have to convert into the minimum. We have to solve that in bench and bone. These are the applications. Zero by knapsack problem, traveling salesman problem. This are the application. Thank you for all. Thank you for all.